Hello everyone, I am Eric. Today I want to talk about LeetCode challenge on June 16, longest duplicate substring. In this problem, we want to find the longest duplicate substring of a given input. For example, for this is banana, and we have some duplicate strings such as A, because we have 3 A here. A, 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 and A here. And we also have AN, AN, AN. And NA is also a duplicate substring, NA and NA. So my mouse is so strange. And we also have ANA and ANA. And we have to return the longest one. So the answer is ANA. And for example 2, this one is A, B, C, D. Because they are all distinct, so it is impossible to have a duplicate substring. So we return an empty string here. In my opinion, I think today's problem is harder than the usual one. And in fact, I think it is the hardest problem in the daily challenge in June. And so my video will be longer this time, so I want to give you an overview. First, I want to introduce a brute force method first. Although it will take, the time complexity is really bad, but it will give us some idea of solving this problem. And then I will use a set to improve the brute force. And third, I will use binary search to improve the previous method. And then I will introduce wrapping cup algorithm. Then I want to introduce the brute force method first. What is a brute force method? If we want to find the maximum duplicate substring, we can find the maximum possible length of the duplicate substring. For example, if the string's length is n, then the maximum possible length of a duplicate substring is n-1. Because if it's n, we cannot have a duplicate substring because we only have one substring. But if it's n-1, we have two substrings, so we may have a duplicate substring. And we can start from n-1 and search for n-2. If we cannot find n-2, we will search n-3. And the first duplicate substring we found must be the longest one. In this example, for this banana example, we will start from k equal to 5. So we have BA, NAN, and AN, ANA, but they are not the same. So k equal to 5 is not okay. And k equal to 4 have BANA, ANAN, NANA, and it is also not okay. No duplicate. But for n is equal to 3, we can find there is a duplicate. So it is okay. So we can return ANA. Then I want to analyze the complexity of this brute force method. First, we will have k from n-1 to 1. So it will take big O1. We have big O1 iterations. And for each iteration, we have to do the pairwise comparison. So it will take big O(n) squared to do the pairwise comparison. And for each comparison, we should compare the character one by one. For example, if I want to compare the BAN with the ANA, I should start from the first character to compare B with A with N with A. So it is also a big O(n) calculation. So the total time complexity in one single iteration will be big O(n) to the power of 3. So the total complexity will be big O(n) times big O(n) to the power of 3. So the total complexity will be big O(n) to the power of 4. Then we want to talk about the second method. Because in the brute force method, we have to do the pairwise comparison in each iteration, but it can set by a hash set. And let me explain how can I do that. For example, for the k is equal to 3 iteration, if we have a hash set here, and then for BAN, because it is not in the hash set, so I just add it into the hash set. And for ANA, because it is not in the hash set neither, so I add it to the hash set. And for NAN, because it is not in the hash set neither, so I add it to the hash set. And ANA is in the hash set, so by the calculation of the hash function, we can find ANA is actually a duplicate string. And if we use this method, we don't have to do the pairwise comparison and save a lot of time. And let me analyze the complexity of this method. Because we have to check this one by one, there will be a big O n. And then for each substring, we have to calculate the hash function. And it will also be a big O n because the length of the substring can be n minus 1. So the total complexity will be big O n squared in one iteration, and we have n iteration. So totally, the time complexity will be n to the power of 3 for this method. And I have submitted this method actually, and it will be time limit sheet. So we have to further improve our method. And how can we improve that? I will go to see the hint. And the first hint said we have to use a binary search. And it tells us how to use a binary search. I think it is a key idea. If we can find a substring that the length is 10, then it means we must have a duplicate substring of 9, 8, 7. And what does it mean? For example, for banana, we can find a substring that is ANA. Then there must be at least 2 ANA. So we must can find a duplicate substring of 2. Here is AN here, and NA here. I think it is very intuitive. And how can we use this property to improve our performance? We can design a binary search method because we know that if we can find a duplicate substring that is equal to X, that means we only have to search the K that is bigger than X. We don't have to search the K that is smaller than X because only the K bigger than X have a better answer. And otherwise, if I cannot find a duplicate substring that the length is equal to K. It means for any K bigger than X, we cannot also find a duplicate substring neither. So we only have to focus on K is smaller than X. And for this problem, we can, for first iteration, we don't have to start with 5, 4, 3, 2, 1. From n minus 1 to 1, we can start from n divided by 2, and then if I can find the duplicate substring, then I found in the n divided by 2 plus 1 to n. If I cannot find the duplicate substring, I will find in the 1 to n divided by 2 minus 1. And in each iteration, we will remove half of the possibility. So the iteration will not be big O n times. It will be big O log n times. And it will improve our performance. So now we have log n iteration, and for each iteration, we have n squared time complexity. So the total time complexity will be n squared log n. And I have submitted this method, and it will be time limit assist in the 10th test case, I think. So we have to further improve our method because we cannot use this method to pass the test case. So we have to think about method to improve our method. And then we just go to the hint. The second hint is that we can use Robin cut algorithm. Because I forgot what is the Robin cut algorithm, I go to Wiki to see what is the Robin cut algorithm. And right here, I think the Robin card algorithm is actually very similar to our second solution here. Why it is to hash the pattern. If we want to find the pattern in a string S, it hash the pattern. Then when it want to do the comparison, it calculates the hash function first. And if there is a collision, I will search it one by one. And if I can search that a string that matches the pattern, then I return the substring. And this method have the same complexity with this method. But there are also some tricks to calculate the hash function. And if you roll down in the wiki, you write it here. It is very, very interesting, I think. It is the most interesting idea of this problem. What it means? It means if we want to calculate the hash function, we don't have to recompute it again and again. We can utilize the last previous hash function we have computed. And how can we do that? I want to give you an example. I have an example here for banana. If I already calculate the hash function of BAN, if I want to calculate the hash function of ANA, I don't have to calculate it again. What I have to do is to use the hash function of the BAN and minus the contribution of B, here the contribution of B, and plus the contribution of A. Then we can get the hash function of ANA by constant time here. So if we get the ANA, we can use the same method to calculate the hash function of NAN. Then we can use the same method to calculate the hash function of ANA. And if we use this method, we will not have a big O n square in one iteration. What we will have is a bigger O n, because I calculate BAN, I still need big O n. However, for later one, I only have one constant time. I think I write C is better because it's not one, but constant time and constant time, which is equal to big O n. Then, so the complexity of this method will be n log n, and we can pass the test case this time. Now let's see the implementation of our method. And the first function, the class, I define a find here. What is find? Find is corresponding to the one iteration here. We have to find whether there is have a duplicate substring in a given length. And that's what I'm doing here. But I want to explain it later. Let's see the main procedure here first. The main procedure here will be a binary search. And the smallest possible duplicate substring is 0, so I update to 0. And then the longest possible duplicate substring is n-1, so I set it right to n-1. Then I do the binary search. I will cut in the middle, because if I cut in the middle, I will remove half of the possibility each time. And then if I can find any duplicate substring here, I can update my answer because it must be a better answer. Then I will search in the right part. So I update the left into mid plus 1. If I cannot find any duplicate substring in the given length, then I have to search in the left part. So I update the right pointer to mid minus 1. Then I complete this main procedure. The only thing I have to remain is the find function. And then we have to go to see the find here. And the find is to find whether there is a duplicate substring of given length. So what we have to do is to calculate the hash function. And I implement here is the hash function here. Here, I just do the same thing. So for each iteration, I should times the base, and the base is 256. I just copy from here because I think we can change to different volume, but I choose 256. And then we can get the hash function. And if you see this part, you will find that to calculate hash function is actually a big O length computation. So for next hash value, I don't want to compute it again. So I can update from the previous hash value, and I can forget what is contribute to the hash function in the first character of the previous iteration, and then I plot the contribution of the last character now. Then we can update the correct hash value here, and it will be big O1, which is much better than big O of length. Then if we can find the hash value, if there is because there might be some collision, so I create a list to search it one by one. If we can find the correct string, then we can return this one. If we cannot, we just return an empty string. Then we finish this part of find, and plus the list main procedure, we can find the final answer, and it is the whole program. I think let me have a snapshot here. And to summarize the problem, I think the problem is actually very hard. I think it is the hardest problem in June. And I divide this problem into 4 parts, and I solve from I propose a brute force method, but it is too slow, and I use a hash set to improve the brute force method. And then if you use binary search, it can be further improved to n squared log n. And if you use a Robin Cobb algorithm with a moving and calculate hash function based on the previous hash function, it can be big N log n. I think this problem is actually very interesting, and there are a lot of brilliant ideas here. And I think the hint is really important. If there are not the hint, I think I cannot come up with the last one. I think it is really hard, but it is really interesting. I hope my video can help you understand this algorithm. Thank you for watching my video, and have a nice day.